Hi there, this is Salman and you're watching the Genesis YouTube channel. Today we will do a question in which we can avoid integration just by remembering a few results from SHM. The question goes like this. A thin rod of length L and mass m moves horizontally on a horizontal surface with velocity u vector directed parallel to its length. At some instant in its motion, it reaches a point O beyond which the surface is rough with a coefficient of friction mu between the surface and the rod. It is found that the rod stops just as it completely enters the rough portion of the surface. Find part A, the speed u of the rod on the smooth part of the surface, and part B, the time duration between the rod entering the rough portion of the surface and stopping. I suggest you pause the video and try this question on your own. These are the answers to the question. We now go ahead with the solution. This figure shows the situation when X length of the rod has entered into the rough region, and this figure shows the free body diagram. I have divided the normal force into two parts, N and N dash, corresponding to the portion of the rod inside and the portion of the rod outside. For the portion of the rod inside, N will be equal to lambda into X into G, where lambda is the linear mass density, which is m by L in this case. I will work throughout with linear mass density here. And mu n is the only force which is retarding the motion, and therefore mass into acceleration is minus mu n. Lambda into L is the total mass. Now, substituting this value of n here, we will immediately get this equation. This is a rectilinear motion with variable acceleration that depends on x. So writing A as v dv by dx and integrating, you see at x is equal to 0, the speed was u, and at some general x, let the speed be v. Integrating, we get this expression, v square is equal to u square minus mu g by L times x square. And now take the square root and write v as dx by dt. Separate out the variables, perform this integration, and you will get x as u by root over of mu g by L sine of root over of mu g by L times t. Now we know that when x equals L, that means when this part goes L distance, that means the complete rod is inside the rough portion, then the speed becomes 0. Substitute this condition in this one. And from here, we will immediately get u is equal to root under mu gl. That is the answer to the first part. Now, substituting this u in this equation for x, we get x like this. I trust you can do the simplification yourself. Now we want the time in which this x is becoming L. So when x is equal to L, solve for time and you will get time as pi by 2 root over of L by mu g. This is not a very difficult question and neither are the integrations too complicated. However, all the results that we just got by integration can be achieved in one single step if we just observe that this equation of motion that we got from the force analysis, this equation of motion is of the form A is equal to minus omega naught square x, which is the equation of an SHM. That means motion of this point, the tip, is the same as that of an SHM. And here, correspondingly, the angular frequency will therefore be root over of mu g by L. Now, the motion of this point is 1/4 the time period. Had it gone in an SHM, it would have gone ahead like this, gone back, and then come back here. That would have been one full cycle. But here it is only going till a distance L and stopping. That means it is only going for 1/4 time period with an amplitude of L. That's the maximum it is moving away from its original position. And it's obvious that this U, this speed with which it enters the rough region is the speed at the mean position of this corresponding SHM. Hence, one single line therefore gives the answer. The motion of the rod is 1/4 oscillation of the SHM with omega naught root over of mu g by L, and A is L, amplitude. Hence, the time required is 1/4 of the time period. Substitute omega naught, you get the answer straight away. U corresponds to the mean position speed, and therefore U is omega naught A. Therefore, substitute the values and you will get root under mu g L. Understand that where time is of essence, especially in competitions, here these kind of observations can really give you an edge. With practice, you will be able to develop and see these kind of patterns in questions. But it is advisable that when you are learning, look out for patterns like this. Try to see whether or not some pattern like this exists. I hope you liked this video. Like, subscribe, and share widely amongst your friends. And as always, till the next time, stay safe and stay healthy, you all.